Modern particle physics relies on the Standard Model and general relativity to describe the universe. Yet to make these equations functional, physicists must manually input dozens of empirical numbers, values derived from particle collisions rather than mathematical necessity. The masses of quarks, the strength of forces, and the mixing angles of neutrinos are currently unexplained. They appear in our models because they were measured in a lab, not because the theory required them to be those specific values. Simplicial Lattice Field Theory, or SLFT, proposes that these constants are not independent variables. In this framework, reality is a discrete geometric vacuum where every physical value is a fixed consequence of the underlying grid structure. This framework constructs the universe using only two fundamental inputs: the spacing between the lattice points and the tension of the lattice itself. If reality operates on this specific geometry, the known physical constants and forces emerge through calculation. The structural constraints of the lattice replace the need for empirical veta fitting. The architectural foundation of SLFT is the D4 root lattice. This four-dimensional mathematical structure achieves the densest possible packing of spheres in 4D space. The unit cell of this lattice is the 24 cell, a self-dual four-dimensional polytope. It contains 24 identical vertices, serving as the repeating geometric block that builds the D4 structure. This infinitely repeating grid creates a rigid, discretized background. This model describes spacetime as a tangible crystalline structure, departing from the smooth, continuous fabric of general relativity. Selecting this specific 4D lattice imposes strict mathematical limits on the system. The geometry dictates which particles, dimensions, and forces can exist based on the symmetries available within the 24 cell. In its undistorted state, the D4 lattice possesses perfect O4 symmetry. All four dimensions are identical and spatial. There is no mathematical distinction between space and time. To produce the universe we observe, the lattice must undergo topological frustration. This is a structural distortion governed by the virial theorem, which balances the kinetic and potential energy within the grid. The math requires the lattice to distort at a specific deterministic angle, the arctangent of 2. As the lattice shears along one axis at this precise angle, the O4 symmetry breaks into O1-3 symmetry. This mechanical shift isolates one dimension from the other three. Time flowing differently than the three spatial dimensions is the mechanical result of this lattice frustration. The signature of our spacetime is a consequence of geometric distortion. The framework extends from the D4 lattice to the broader F4 root system. This mathematical structure contains the vectors necessary to define the fundamental forces. The F4 root system contains exactly 48 distinct vectors. These 48 roots partition into two sectors: 24 long roots and 24 short roots. In SLFT, the long roots represent gauge fields, the forces, while the short roots represent matter. The 24 long roots map to the SU3, SU2, and U1 groups. These are the specific mathematical symmetries required for the strong, weak, and electromagnetic interactions found in particle physics. Because the geometry is constrained by triality invariance, hypercharge is fixed relative to the other forces. This derives the Weinberg angle at specific ratios, calculating a value of 37/160 at the electroweak scale. The fundamental forces are the direct geometric result of the 48 F4 roots unpacking into the visible universe. Placing matter on a discrete grid usually triggers the Nielsen-Niinomoya theorem. This rule states that chiral fermions, like quarks, cannot exist on a lattice without generating unphysical clone particles called doublers. SLFT bypasses this restriction by applying a Wilson-Dirac operator to the specific geometry of the 24 cell. This process generates an adjacency spectrum. The geometry restricts all possible particle states to exactly 5 discrete eigenvalues: 8, 4, 0, -2, and -4. Physical representations lock onto these lines. The 8 and 4 hold scalars and vectors, while tensors and spinors occupy the lower eigenvalues. The -2 line provides an 8-dimensional space for spinors. Through the property of SO8 triality, this space hosts exactly 3 fermion gyrations. The existence of three generations of matter, the electron, muon, and tau, is a mathematical requirement of the lattice spectrum, solving the doubler problem. To find the precise values of nature's constants, we analyze the boundary of the 24 cell. This boundary is an S3 topology composed of 96 face units. A discrete Hodge decomposition splits these 96 units into 73 boundary operator ranks and 23 frozen modes. These counts define the degrees of freedom in the lattice action. By applying a villain action with an instanton fugacity of 1/3 to this 73 and 23 split, the coupling strengths of the forces become fixed by the available phase space. This calculation derives the fine structure constant at 137.06. Simultaneously, using the Pell identity, where 17 squared minus 2 times 12 squared equals 1, the framework locates the Higgs mass at 125.25 giga-electron-volts. The same 73 and 23 geometric ratio extends to cosmic scales, dictating the dark matter to baryon ratio of 173/32. These constants are the inherent fixed ratios of the 24-cell boundary. On a cosmic scale, the collective behavior of trillions of these fundamental geometric cells gives rise to gravity. In SLFT, gravity is an emergent property of the D4 lattice's elasticity, rather than a fundamental force found in the microscopic roots. As the lattice strings deform under tension, they create the inverse square potential well that defines Newtonian gravity. This structure also addresses the cosmological constant problem. Quantum vacuum energy is expected to be massive, yet we observe a very small cosmological constant. SLFT resolves this through Poincare duality on the S3 boundary. This topological folding causes the bulk vacuum energy to cancel itself out. Gravity and dark energy arise from the mechanical stretching and topological folding of the underlying 4D crystal. The SLFT framework derives space-time signature, the nature of force interactions, the three generations of matter, and the Higgs boson mass from a single geometric source. This complex physical landscape is produced by only two free parameters, lattice spacing and tension. Here, the properties of the universe derive from the internal logic of the D4 lattice. Physics becomes a study of the geometric constraints inherent in a four-dimensional crystal. The fundamental constants of our universe, from electron charge to dark matter density, are the logical outputs of a discretized geometric vacuum.